Hello everyone. Today we're going to continue 15.1 day 2 and we're going to continue explore the logarithm functions, and we're going to start by evaluating a couple of logarithm expressions. And the first one is to evaluate f of x with the different values here. So the first one, we're going to let x equal to 4. That means wherever x you see, you're going to substitute 4 in there. And so it looks like x is over here. So let's take a look and evaluate that. And we're going to just pretend that we do not know what the answer is. So that's going to be just y. So I'm going to let that equal to y. So y is equal to the log of 1/2 to the x. Remember yesterday's lesson I told you guys that following the arrow is important. So I'm going to show you guys what that means right now. Following the arrow means we're going to start from the base and to rewrite this logarithm as an exponential. That will help us get rid of the word log, since that seems to be confusing. So if we just rewrite this as log without the log, then that would be helping to solve the problem. And we have 1/2 to the base right here. We're going to start with the base of 1/2. Following the arrow to the other side, we have a raised to the power of y. It's going to give us this x, and I forgot to replace the x right here with 4. So now, again, we have already eliminated log by rewriting this in exponential form. 1/2 to the y equals 4. Now, this is still in logarithm form, but it just looks different. So this is still a logarithm function because notice the y is in the power. So now we're going to solve this, and the way that we would attempt to solve this is going to rewrite the 1/2 as 2 to the negative 1 power. And that's going to be multiplying by y. I'm going to rewrite the 4 as 2 squared. And so we're going to just simplify the exponent. That will give us 2 to the negative y equals 2 squared. And then therefore, because the base are equal, we have y equals negative y equals 2. And then switching the sign, we have y equals negative 2. So now we have solved the problem, and we have y is equal to negative 2 is the answer for that problem. Let's take a look at the next one. I'm going to try one more. And f of x is, this time, x is 1/32. So again, we're going to let this equal to y. So y is going to equal to the log base of 1/2 of 1/32. And again, following the arrow, we're going to start with the base of 1/2 to the y power equals 1/32. That will help us get rid of log. And rewriting again on the left side, 2 to the negative 1 times y. And 1/32, that's 2 to the 5th. So 1 over will be 2 to the negative 5. And so we have 2 to the negative y equals 2 to the negative 5. And therefore, because base are equal, we have the exponents. Negative y equals negative 5. And dividing both sides by negative 1, we have y equals 5. So the answer is 5. And the last one here is, again, evaluating, and we're going to let this equal to y. So y equals log base of 1/2, the same problem, of 2 radical 2. And I don't know if you recall, radical 2 is actually 1/2 power. So we got, let me just go ahead and finish writing. Follow the arrow. 1/2 to the y is equal to 2 radical 2. And again, we're going to rewrite this. This is a 1 power, and I don't know if you remember, but radical 2 is actually 1/2 power. So we got 2 to the 1 power and 2 to the 1/2 power. So together, that's going to give us 2 to the 3/2 power and 2 to the negative 1 on the left times y. That will give us 2 to the negative y. And again, because the base are equal, we have the exponents are the same, and therefore gives us the answer of y equals negative 3/2 as an answer, and that will give us negative 3/2. So those are the answers evaluating the logarithm with a given x. And it is time for you to try a few of your own, and then make sure to pause the video before you look at the answers. So these are the problems that you're going to try right now. And I've already worked them out, so hopefully you've had a chance to try the problems. And you can pause the video at this time to check to see if you got the correct answer, and follow the steps here to make sure that you understand every step. And you can go back to the examples that I did with you earlier to see if you missed anything. And let's go on and take a look at the actual logarithm functions on the calculator. So evaluating on the calculator, on the scientific calculator. So first we have log. If you just have the word log, L-O-G, it just means there is a base of 10. So regardless whether you see the 10 or not, it automatically means base of 10. In fact, on your calculator, there is only one button that says log, log, and that is the log base of 10. Now remember, you got all kinds of log. You got log base of 2, log base of 3, log base of 5, etc., etc. You have infinity number of log. So there is no way we could fit all of those buttons on the calculator, and so we only have one. So the log is the only one. So let's talk about evaluating the log function. The log base 10 of 1 is always going to equal to 0, and that's true for every single log. No matter what it is, the log base, any base of 1 is always going to be 0. And that is because following the arrow, you'll understand 10 to the 0 is 1. 2 to the 0 is 1. Anything to the 0 power is always gives you 1. So therefore, if you take the logarithm of 1 of anything, it'll always give you 0. So you can go ahead and try to find the button on your calculator and take the log of 1 and see if you got 0. And that same thing goes for natural log. Natural log is the same thing as log, except you can understand that as a base e instead of 2 or 3 or 5 or 10. It's the log base of e for exponential. Remember that? And so e is the number 2.718, so it's a base log of 2.7. And so that still, if you find the log, natural log of 1 will always still give you 0. So these are all so there's a total of 2 log function buttons on your calculator, and that is all. So now I need you to go, and unfortunately I cannot stop the video and go into the app, otherwise it will quit on me. So you need to go into your calculator and locate those buttons and start finding the values. So we're going to have you practice this on your calculator while I do it on my other calculator. So let's take the calculator and find the common logarithm. Well, common logarithm is also known as just log. And then natural log is just ln. So those are the two buttons that we saw on your calculator earlier. And so looking for the answers is pretty easy. You just substitute and just plug it into your calculator and find the answer. So the log of 0.42 value should be approximately, and we're going to have approximate signs, negative 0.377. So go ahead and try that and see if you're getting that value to see if your calculator is in sync. And the natural log of 0.42 will give us negative 0.868. So those are the two values. And then we're going to continue. Log of 4 is approximately 602. And the natural log of 4 is 1.386. So those are the values that I have. And then you can go ahead and try to find the log of 0.25 and the natural log. And go ahead and try it. And I have the answer of negative 0.602 for the log and a negative 1.386 for the natural log. And so those are the answers. So make sure you practice these problems on your calculator to make sure that you're getting the answers. Next, we're going to take a look at a couple of word problems because this is the last lesson in 15.1. Example 3. There is a type of bacteria that is used to turn milk into yogurt, and the population P of the colony of 3,500 bacteria at a time can be modeled by this function right here, which I've already written on the bottom. And the question is asking how long does it take to the population to reach 1.792 thousand. So 1,792,000. And we're going to start by solving for time because it's asking how long does it take. So we're going to actually solve the problem for t. And the first thing that we need to do is undo that 3,500 in front because we want to get t by itself. And therefore, we need to start by dividing by 3,500. And so we have P over 3500 is equal to 2 to the T over 73. So the next thing we need to do is bring the T down from the exponent to the base. And to do that, we need to apply the inverse of log of base. So let me just give you a little side review here. To undo the power of base 2 with the to get rid of that, we are going to need to apply the log base of 2, because remember that 2, to get x, basically we want to get a 1 in front, that log 2 of 1, of 2 is equal to 1, because 2 to the 1 power it's going to give you 2. So anything that has a base, whatever that number is, let's say this is 5, then log base 5 of 5 is also going to be 1. So to get rid of that, we need to apply the inverse. So likewise, we're going to take the log base 2 on both sides. And that will help us get rid of that, because remember, again, refer to here, log 2 of 2 equals 1. So log 2 of 2, that will give us 1, and I'll have T over 73 on the right hand side, and I have this whole thing, log 2 of P over 3500 on the left side. And the last thing we're going to do is to times 73 on both sides. And multiplying by 73, I will have this is what T equals to. So that's going to equal to T. And so now we're going to answer the question, and we're going to let P equal to this number right here. So solving the problem, we're going to have T equals 73 times the log base 2 of 1792000 over 3500. And we're going to just simplify this a little bit. On your calculator, you can follow me. The log 2, 1792000 divided by 3500, that should give you an answer of 512. And now we're going to actually rewrite 512 as 2 to the 9 power. So bringing everything down, we have 73 times log. Remember I said log 2 of 2 will give us 1, so that will cancel out. So we actually just have 73 times 9, which is 657, and this unit is minutes. And if you want to convert that to hours, you can just divide it by 60, and that'll be approximately 10.95 or 11 hours. So that will be the answer to this question. So hopefully you understand that process. If you need to go back and review the video, you may. We're going to do the last problem here. And that is the intensity level L in decibels of a sound is given by the formula right here, and where I is the intensity in watts per square meter, and IO is the intensity of the softest audible sound, about 10 to the negative 12. What is the intensity level of a rock concert if the sound intensity is 3.2? So if I've already gone ahead and evaluated the I for the intensity, which is given here, 3.2, over the I naught, which is 10 to the negative 12 into the equation. So now all we need to do is solve the problem. So we're going to start by just dividing by 3.2 by negative 10 to the negative 12. So if you understand that it's actually just 3.2 times 10 to the positive 12, rewriting, because on the bottom is negative, so we put it on top. The 10 to the negative 12 becomes 10 to the positive 12. Taking the log of that will give us approximately 12.5, and then multiplying by 10 will give us 125 decibels. And that is the intensity of the sound for 3.2 watt per meter square. And that is the end of the problem. And I believe this is a wrap for day 2. So today's assignment, you're going to do the book set and finish HRW, just keep going, and then copy notes for 15.2 day 1. Have a nice day.